And please, if you notice that I'm not recording, sometimes I stop it because if there's going to be a pause, then I just stop it because it takes up so much space in the computer. But if you see that I'm not recording, then tell me and I'll record. It'll remind me. Okay, so I have it on record now. These two problems, I'm giving you 3 or 4 minutes to do that. Okay, I think we had enough time to do these two problems. Let's just remind ourselves how to do it so we can go on further than that. This, remember, this is a subtraction. We either have subtraction or addition. When you have either of those operations, what you're looking for is like terms, where the letter parts, the literal parts have to be identical. The only thing can be different is a number in front. Now it says subtract negative 8x squared y plus 8xy squared minus 2xy plus 8 from 3x squared y minus 10xy squared plus 5xy minus 12. Now be careful when you're reading these type of problems. When you're subtracting, the order in which you do it is very important. And it says subtract the first one from the second, which means you have to put the 3x squared y minus the 10xy squared plus 5xy minus 12 first, and then minus the negative 8x squared y plus 8xy squared minus 2xy plus 8. So be sure if it's a word problem that says subtract that you make sure to put the one that's after the word from first. This goes first, that goes second. Don't forget, when we have these things, no numbers in front of the parentheses, it's as if there is one. So this ends up being 3x squared y minus 10xy squared plus 5xy minus 12, because this was a positive one. This is a negative one, so it's going to change all those signs. So negative times negative becomes plus 8x squared y minus 8xy squared plus 2xy and minus 8. So all the terms in the second parentheses got switched. Their signs got switched because this is a subtraction. We're multiplying by a negative number. Now let's be careful. Wait, this one is an x squared y. So we have to only add it to another x squared y, which is this 8. So 3 and 8 gives me 11, so it becomes 11x squared y. The next term I see is negative 10xy squared. That's not a like term, even though it looks very similar. It has to be identical in terms of the letter parts. There's a negative 10xy squared and a negative 8xy squared. Those are like terms. Negative 10 and negative 8 is negative 18. So this becomes negative 18xy squared. Now we have a positive 5xy and a positive 2xy. Those are like terms, and 5 and 2 is 7. So this becomes plus 7xy. And finally, we have negative 12 and negative 8, which gives me negative 20. So your answer comes out to be 11x squared y minus 18xy squared plus 7xy minus 20. You can't simplify it any further. That is the result of subtracting that first polynomial from the second polynomial. Okay, the next thing we have is a multiplication example where we have actually we're multiplying two binomials. And we know when we're multiplying binomials, we do what's called FOIL. First, outer, inner, last. So first we multiply the first two terms. 8 times 8 is 64. Remember, when you're multiplying, it doesn't have to be like terms. You have to multiply the numbers together. And when you multiply the letters, the variables together, it means you're adding their exponents. So we did our first was 8 times 8. Next, we do outer. O stands for outer, which means the furthest two terms. The 8 times a positive x, which gives us plus 8x. Then we do inner, the closest together, the ones that are right attached at the parentheses, which is the negative x here and the positive and the 8 there, and negative 8 times negative x times 8 is negative 8x. And finally, last is the last two terms in each parentheses, negative 6 times negative x times positive x, which is negative x squared. And when I combine the like terms, usually the outer and the inner term do turn out to be like terms. When we combine them, the 64 stays, the positive 8x and the negative 8x cancel out because they're 8 and negative 8 add up to 0. And finally, I have negative x squared. Usually when we are multiplying two binomials, our answer is a trinomial. You usually get 3 terms. In this case, we multiply two binomials and got a binomial as an answer. And actually, if we look at the pattern, we will see that the binomials that we were multiplying together looked very similar. They were identical except for one had a minus between the two terms and the other one had a plus. Those type of binomials are called conjugate binomials. When I use the term conjugate binomials, I'm talking about two binomials that are almost identical. For example, if I have 6x plus 7, the conjugate binomial will be 6x minus 7. The exact same two terms, except one has a plus and one has a minus. It turns out whenever you multiply conjugate binomials, when you do the FOIL, because that's how you have to multiply binomials, the outer and the inner terms will turn out to be the exact same thing, except one will be a positive and one will be a negative. Here the outer was a positive 8x. Here the inner was a negative 8x. And when you add two terms that are identical, except one is positive, one is negative, they cancel each other out. And that's why when you multiply conjugate binomials, your answer doesn't turn out to be a trinomial, it turns out to be a binomial. And it turns out to be just the first, the 8 times the 8, and the last, the negative x times the positive x, which is the negative x squared. That would happen over here as well. If I tried to multiply 6x plus 7 times 6x minus 7, if I notice that they are conjugate binomials, I can save myself time by just multiplying the first terms together, 6x times 6x, which is 36x squared. Don't forget x times x is x squared. And the two last terms together, positive 7 times negative 7 is minus 49. These are conjugate binomials. When I multiply them, they will always turn out to be a binomial. If you tried doing it the full way, you would see that the outer would be negative 42x and the inner is positive 42x, and they would cancel out. So if you know they're going to cancel out, why bother do the extra work? So that's pretty much where we had left off last time. Let's just do one more multiplication. Let me see if I can find something on oh yeah, okay. So let's do, here's what I want to do next. Suppose I have not two binomials that I want to multiply, but I have a binomial and a trinomial. What if I have more than two terms in my example? Let's say I have 2x minus 5 times 3x squared plus 7x minus 2. I want to multiply the binomial 2x minus 5 by the trinomial 3x squared plus 7x minus 2. Now, I can't call this FOIL. FOIL only works when you have two terms times two terms. Now I have two terms times three terms. But the concept, the way we did it, does work. What we're going to do is we're going to use the distributive property twice. We're first going to take the 2x from the first parentheses and you distribute it to all the terms in the second parentheses. So I'll multiply the 2x times the 3x squared. So 2 times 3 will give me 6. X times x squared. Remember, we're adding exponents, and this is exponent of 1. 1 and 2 is 3. So this is 6x to the third. Then I take the 2x and multiply by the 7x, which gives me 14x squared. Then I take the 2x and multiply by the -2, which gives me -4x. After I've multiplied everything by the 2x, I take my next term. Now remember, the next term is not just plain 5, it's a -5. The sign goes together with the number it precedes. So this is a negative in front of the 5. I'm going to multiply now everything by -5. -5 times 3x squared will give me -15x squared. Then I'll do -5 times 7x. So -5 and 7 is -35x. And finally, I'll do the -5 times the -2, which will give me +10. And now I go and I look for any like terms. So I just bring down the 6x to the third. There's a 14x squared and a -15x squared. Those are like terms. 14 minus 15 is -1. So that's -1x squared, or just -x squared. Then I have a -4x and a -35x. Those are like terms. -4 and -35 is -39. So we have -39x. And finally, just the +10, there's no like term. And usually what happens when you have a binomial times a trinomial, your final answer turns out to have 4 terms. So that's how you multiply. And you could continue this. So let's say you had a trinomial times a trinomial. Again, you just continuously use the distributive property until you've multiplied every term in the first parentheses with every term in the second parentheses, and then you go on and you combine your like terms. Now, if you had something like this, let's say it's a different problem. Suppose I had 3 things that I want to multiply. How do we multiply 3 parentheses? Let's say I have x plus 2 times x minus 2 times x squared minus 4. Let's say I have that. I have 3 binomials I want to multiply. How do I go about multiplying 3 things? Well, let's see. Let's just think what we would do if we just had numbers. Let's say I had 2 times 3 times 4. How do we go about multiplying 3 numbers? Actually, multiplication is something called a binary operation. Binary means 2 numbers. When I multiply, I really only multiply 2 at a time. So if I have 3 things that I want to multiply, what I want to do is first multiply the first 2. 2 times 3. That'll give me 6. And then take the 6, the answer I just got, and multiply by the last one. So your final answer is 24. Notice you do not use distributive property here because these are all multiplications, not a multiplying and an addition. Distributive is when you have multiplication times things that are added. But when you have 3 things multiply, you just take your first term, 2 terms, you multiply those together, get your answer, and then multiply it by the final answer. So if I think about it, I'm going to do the same thing over here. The first thing I'm going to do is I'm going to multiply the x plus 2 times the x minus 2. Those are the first 2 parentheses. And I notice that these 2 happen to be conjugate binomials. They are identical except one has a plus and one has a minus, which means that I don't have to do the whole FOIL. I could just do first and last, save myself some time. So x times x will give me x squared, and +2 times -2 will give me -4. So that would be my first step. I multiply the first 2 parentheses together. Now that I have the answer between the first 2, now I have to take the next 2 and multiply them. So I take my answer, which is the x squared minus 4, and multiply it by the other x squared minus 4. These are not conjugate binomials. They are identical binomials. What we're really doing is not multiplying two conjugates. What we're really doing is multiplying something by itself. And that's just regular FOIL. The only shortcut comes when you have conjugates. These are not conjugates. So I'm going to do what I did over here. I'm going to, actually I could use FOIL here because these are both binomials. So first, x squared times x squared is x to the 4th. Remember, we add our exponents. Outer, that's x squared times negative 4 is negative 4x squared. Inner is negative 4 times x squared, which is again another negative 4x squared. Because these are, you're multiplying something by itself, it turns out that the outers and the inners are exactly the same. The outer is negative 4x squared, the inner is also negative 4x squared. And finally, last, negative 4 times negative 4 is positive 16. Be very careful with your summings. And again, my middle terms are like terms. Now, these do not cancel out because they're both negative. So my final answer comes out to be x fourth. Negative 4 is negative 8x squared plus 16. If you notice, that middle term is just simply the negative 4x squared. If you multiply the x squared and then negative 4, you get negative 4x squared. If you double it, that's what that middle term came out to be. Sometimes that is a pattern as well. But your answer is not a binomial, but a trinomial because these were not conjugates. So that's how you go about multiplying something with 3 terms. Okay, I'm going to give you an example to try. And I'll give you a couple minutes to do it, and then we'll go on to the next topic. Suppose I have x plus 4 times 2x squared minus 5x plus 6. Let's see if you could multiply this binomial by this trinomial and come out with your answer in simplest form. While you are doing that, I'm going to be calling attendance, so please listen for your name. Jesus Antonio. Jesus Jackson. Good morning. Tiffany, I know you're here. Tiffany, we were speaking before. Kayla Brantley. Tashana Caesar. Good morning. Dion Carter. Dion. Wensley. I think I saw you before. Wensley here? No. Tatiana. Good morning. Awa. Good morning. Ashay. Good morning. Eliana. Good morning. Christopher. Emily Gomez. Good morning. Anastasia. Anastasia Guerra. Xanabu. Xanabu. Ismail.
Hey,
Good morning.
good morning.
Jaden. Jaden. Ashiana. Anijah. Thomas. Thomas John.
I'm here.
Good morning.
Morning.
Paul. Paul LeBrun.
Here.
Hi,
Oh.
good morning.
Morning.
Ashley. Pretty sure I saw Ashley here before. Ashley Moorhead. Angelica. Good morning. Akeem. Akeem Richards. Craig Ricketts. Giovanni Rowe. Devonly. Najay Waddell. Okay. The best turnout today. Oh, thank you.
Wait, did you call my name?
Who's that?
Tayon.
Hang on, did I? No, I did. I don't remember that I called your name. How did it? I don't know how I missed you. Sorry.
It's okay.
By the way, if you ever come on and you see it doesn't, it seems like I already took attendance, just send me the chat. No. Okay. I think I got everybody now. Okay, Giovanni, I got you now. Okay, let me just remind you that the test was supposed to be completed for today. I did give an extension. I think it's either until Thursday or Friday, but please make sure you complete it by then. Anybody who wanted to redo their test because they weren't happy with their grade, just send me an email. And I have reset a few people's. I'll reset. As a matter of fact, what I do is I just reset the ones you got wrong. I don't think it's necessary for you to do the whole test again. Just do the ones that you got wrong. I'll extend the time for you. Like if you got 3 wrong and you wanted to redo those 3, I won't give you another 45 minutes, but I'll probably give you 20 minutes, depending on how many you're doing. And this is the first test, and I like to see that you get used to taking those tests the way, because some of our tests are going to be like this. So I want you to be used to it. So again, if you want to redo some of it because you weren't sure if you got why you got things wrong, just send me an email. Again, I won't extend it again. I extended it until Thursday. You'll have another 2 days to finish this. Okay. So let's look how we do this. Again, this is a binomial times a trinomial. We're going to use that. distributive property twice. We're gonna take the x and multiply it by everything, then we're gonna take the 4 and multiply it by everything. So first multiplying everything by the x times 2x squared. Remember, this is like a 1 in front of it. The 1 times the 2 is 2. The x times the x squared is x to the third. Then we take the x and multiply it by the negative 5x. Again, 1 times negative 5 is negative 5. And the x times the x is x squared. And finally, we multiply the x times the 6, and of course that gives us 6x. So now we've finished multiplying everything by the x. We take the next term, which is positive 4, and we're going to multiply everything by positive 4. So 4 times 2x squared is going to give us positive 8x squared. 4 times negative 5x is negative 20x. And finally, 4 times 6 is 24, positive 24. And again, I look for my like terms. There's only one 2x cubed term, so that comes down. Then we have a negative 5x squared and a positive 8x squared, which gives me positive 3x squared. Negative 5 and 8 is positive 3. The positive 6x and the negative 20x. 6 and negative 20 is negative 14. So this gives me negative 14x. And there's just the 24, nothing to combine it with. So here's, I hope some of you did get this answer. I see. Okay, and Angelica, thank you. Okay, looks like a bunch of you got it right. I'm glad to see that. So now let's go on to the next topic. We have covered so far adding, subtracting, and multiplying of polynomials. And we said division of polynomials we're actually not covering in this chapter. We're going to do something that's similar to division, but is not exactly division. It's something called factoring. Okay. Let me describe the difference between factoring and between dividing. And I'm going to describe it in terms of just regular numbers, but the concept is going to be the same even if you have polynomials. When you're dividing, suppose I tell you divide 18 by 6. We sometimes write that as 18 over 6. And of course, we can just stick it into our calculators. This happens to be a relatively easy one. 18 divided by 6 will give me 3. We say when the answer comes out to be a whole number, we say that 6 is a factor of 18 because it divides evenly into 18. Though I could have something like this where I'd have 21 divided by 2. And if I stick it into my calculator, I get 10 and a half. It's not, 2 is not a factor of 21. Sometimes we even leave our answer 21 over 2. It can't be simplified any further. We can say 10 and a half, or we could say 10.5, which is probably what you would get if you stuck it into your calculator. So sometimes we get a perfect whole number because the original number went evenly into the original, what's called the dividend. Sometimes we get fractions or decimals. That's division. What then is factoring? Well, let's start with this, say, number 18. First of all, when you're factoring, where you're trying to find the factors of a number, you're not told what to divide it by. You have to figure out a number that divides evenly into the original number. Now, I know that 18 can be divided by 3. One of the factors of 18 is 3. Once I know one factor, I can figure out the other factor by taking the original number and dividing it by that. So I know if I divide 18 by 3, it'll give me 6. Yeah, is there a question?
I do. Can you hear me clearly?
Yes.
Okay. So for the one that the problem that you did before, the 21/2, that would be the answer? That was a question, not a quiz or the exam.
The answer would be 10.5. It would be something that you would, because it's a division problem.
Okay, got you. Thank you.
Deanne, were you here the whole time? I don't think I marked you here.
No, I stepped away for a minute, Professor.
Oh, okay. Got you now.
Thank you.
Okay. Well, let's look at this 21. Now, you know that 2 is not a factor of 21, because if I try to divide 21 by 2, it doesn't come out evenly. It doesn't come out to be a whole number. It comes out to be the decimal or a fraction. But I do know that there are numbers that go evenly into 21. One of the numbers that goes evenly into 21 is 7. We say 7 is a factor of 21. Well, how do I find the other factor? Once I know one factor, I can figure out the other factor by dividing the 21 by the 7, and that gives me the 3. In other words, 21 has 2 factors, 7 and 3. 18 has 2 factors, 3 and 6. Actually, you could even actually go further on this, so this you couldn't. If something doesn't have any factors, and we say it's a prime number. Okay, so now we're going to be talking about not dividing polynomials, we're going to be talking about factoring polynomials. And factoring polynomials is trying to break it down into the original things you were multiplying in order to get your final answer. In other words, if I want to factor 21, I want to break it down into 7 and 3, because I know 7 times 3 gives me 21. So that's what factoring is about. Now, the thing is with factoring, especially a factoring of polynomials, there are several different ways things can be factored. And what I'm going to do is I'm going to start with one type of factoring. After we do that time, I'm going to look at another type. By the end, we'll have like 3 or 4 different types of factoring we can do. And then at the end, I'll tell you what you should look for first, etc. But in the basic thing we're looking for is to try, if we have a polynomial, is to break it down into smaller polynomials or monomials that when we multiply them together will give us our original example. Now, the first type of factoring that we look for, as I said, we're going to do this in a very standard way. We're always going to look for this thing first, look for that thing next, look for that thing. We want to be organized about it. The first type of factoring to look for is something called a common, I'm going to put this in parentheses, monomial factor. It happens to be an easy type of factoring to do. It doesn't always work. Not every example will have a common monomial factor. But it's the first thing we always want to look for. And I have to tell you, it's the thing that most people neglect. They go on to the other type of factoring, they forget about this. This is always your first step. So if I were to give you something that looks like 12x to the fourth minus 16x squared, which happens to be a binomial, and I wanted to find a common factor, because again, I'm not going to constantly say common monomial, common factor. Here's what I do. I do it in 2 steps. I first look at the coefficients, 12 and 16. And if the first number actually is a negative, has a negative in front of it, I include that negative as part of the common factor. But this is a positive number that we're starting with. Our leading coefficient, the first coefficient we see, is positive. We look for the largest number that will go into both the 12 and the 16. And I think everybody's going to agree that it's going to be a 4. So that's the common factor of the coefficients. After you've found the common factor of the numbers, then you go on to the variables. And the variable part actually is going to be easy to find the common factor. This is an x fourth and this is an x squared. The common factor is always the lower exponent. If they both have x's in them, then take the lower exponent, which in this case is x squared, and that will give you your common factor. If one of them has x's, but the other one doesn't, then there's no common factor with the x's. If there are more letters, if there would be y's, I do the same thing with the y's. Again, pick the lowest exponent of the y's. Okay, once I've done that, I have found the largest common factor, the greatest common factor, sometimes called the GCF. Okay, now remember, when you're factoring, you have to do 2 things. You have to find the 2 things that multiply together to give you the original example. So we found one of the factors. How do we go about finding the other factor? Well, let's remember, if we said one of the factors of 21 was 7, the way we found the second factor is that we took the 21 and we divided it by the 7. 21 divided by 7 is 3. So the second factor was 3. In other words, now you can use division. So the same thing over here. I have one factor. To find the other factor, I'm going to take this common factor 4x squared and divide it into each one of these terms. I'm sort of doing the opposite of the distributive property. Instead of multiplying each term by the number on the outside, I'm now dividing everything. And I do it step by step. First, I'm going to put a parentheses. I'm going to divide the 4 into the 12, and that'll give me 3. And I'll divide the x squared into the x fourth. Now remember, when you're dividing, what you do with the exponents is you subtract. You subtract the larger exponent minus smaller. 4 minus 2 is 2. So the first term becomes 3x squared. After you've done that, question? After you do that, you go to the next term. You divide the 4 into negative 16, which gives you negative 4. And then you divide the x squared into the x squared. Now, when you divide x squared by x squared, the 2 minus the 2 gives you an exponent of 0. Now, an exponent of 0 doesn't mean there's an x there. It means that the x has canceled out. X to the 0 is really just a plain 1. Not a 1x, just a plain 1. So anytime you're dividing a variable by itself with the exact same exponent, like we have here, x squared into x squared, it cancels out. So my final answer to this example is 4x squared on the outside, parentheses 3x squared minus 4 on the inside. We have factored out the greatest common factor. Okay, let's see if I can give you another example. I'm going to give you this one to try on your own. Ten x fourth y squared plus 20 x cubed y cubed plus 30 x squared y fourth. Okay, I'm giving you this polynomial. I'm giving you about 2 minutes to try and find the greatest common factor. Okay, so let's see if we can do this together. Again, I look first at the leading, these coefficients. This is a 10, this is a 20, this is a 30. The number that goes into each one of them, the largest common factor of those three numbers, of the 10, the 20, and 30, is obviously 10. So I put that down. Once I have taken care of the coefficients, I now go to the variables. X fourth, x cubed, x through 2. I'm just looking at the x's now. The greatest common factor is the one with the lowest exponent, which is the x2, the x squared. And I have y squared, y cubed, y fourth. Again, the lowest exponent is the 2. So my greatest common factor of this polynomial is 10x squared y squared. I've done half the work. Now I have to find the other factor, the one that's in the parentheses. So I divide the 10 into the 10, it cancels. The x squared into the x fourth. Remember, now I'm going to subtract the exponents. 4 minus 2 is 2. That gives me x squared. If you wanted to, you could put a 1 there, but you don't have to. Then you have the y squared into the y squared, that cancels out. So my first term comes out to be x squared. Let me make a comment. If every single thing cancels out, the 10, let's say this would have been 10x squared y squared, and this was 10x squared y squared. I don't leave it blank, I have to put a 1. You are dividing, so if everything cancels out, your answer is 1. It's not 0. It's not nothing, it's a 1. But in this case, we had an x squared. You could have left it 1x squared, but usually we write it just x squared. Then I go to the next term. 10 into 20 gives me 2. Positive 2. X squared into x cubed. 3 minus 2 is 1, so that's x to the 1, or just plain x. Y squared into y cubed, again, is just plain y. And finally, I do 10 into 30 gives me 3. X squared into x squared cancels, because as soon as your exponent is 0, it means it's canceled out. You don't have to put it in. And y squared into y4, 4 minus 2 is 2. So your final answer comes out to be 10x squared y squared on the outside, x squared plus 2xy plus 3y squared on the inside. When you're doing a factoring problem, it's not enough just to write the common factor. You have to write the whole expression. Because if I would multiply these together, if I would use a distributive property on this, I would come back to my original statement, my original polynomial. Okay, now sometimes what we have is not just a common monomial factor, we could even have a common binomial factor. For example, I could have something that looks like this. Five x times a minus 2b minus 3y times a minus 2b. If you look at this, this is this expression. It looks a little strange because I have a monomial times a binomial minus another monomial times a binomial. It's not like everything is all individual terms. But what I do notice is that the binomials, that they're both being multiplied, but the 5x is being multiplied by the binomial a minus 2b, and the negative 3y is multiplied by the binomial a minus 2b. There is a common binomial factor. And what we often do in that case is we factor out that common factor of a minus 2b. What we do is we take the a minus 2b, the common factor, the common parentheses that they both have, put it in front, and in our second parentheses, we put the numbers or the expressions that it's being multiplied by. So first I'll put the 5x, and then I'll put the negative 3y. So that I end up, after I factored this whole thing, with two binomials multiplying each other. This is the better way. If we want to factor, if there's a common binomial factor, just put it in the front as your first parentheses, and in your second parentheses, just put the two expressions that were in front of it. Because that's what this is saying. If I take, this would be the a minus 2b times the 5x, if we use the distributive property, which would be this, and the a minus 2b times the negative 3y, which would be this. So we factored out this common binomial factor. I'm going to give you one to try like this. Suppose I gave you this, 3a times x minus y minus 7b times x minus 1. Okay, I'm giving you a minute to try this one and see if you could do that. Okay, Dion, great. I see you have an answer. And that is absolutely correct. If you notice, we have a common binomial factor of x minus y. So we're going to take that x minus y and put it in the front. And in the second parentheses, we're going to put the things that are on the outside of each parentheses. The 3a and the negative 7b. So what we end up with an expression that is the product of two binomials. So this is the answer to that expression in factored form. Okay, now, why do we talk about this binomial factor? Because it's going to help us do something that's called factoring by grouping. So we know how to take out a common factor. That's our first type of factor, is factoring a common factor. Sometimes it's a single term, a monomial, sometimes it's a binomial. The next type of factor we're going to talk about is something called grouping, factoring by grouping. You will see that basically each type of factoring really builds on the type that we talked about before. So we've already talked about a GCF, greatest common factor. That's what we were doing. What I'll just call a common factor. We're now going on to the second type, which is called grouping. Let me give you an example of how to factor by grouping. Now, usually this grouping method is used when you have a polynomial that has 4 terms. It's not a trinomial, it's a 4-termed expression. Doesn't have a special name. It's a 4-term polynomial. So let's say I have something that looks like this. 3xy squared minus 6y squared plus 4x minus. Okay, again, we're looking to factor this polynomial. And again, our first step whenever we do factoring is to look, is there a GCF? Is there a greatest common factor? And if I look at it, first of all, look at the numbers. There's a 3 here and a 6, but the next one is 4. There's no number that goes into 3, 6, 4, and 8. There's no common number. And in terms of the letters, this has an X, But this one doesn't. And this has a y squared, but this one doesn't have anything. There's no one thing that goes into all four of those examples. If there were, we would take it out. We would factor out the greatest common factor. So what we sometimes do is we group our expression. There are 4 terms. Let's make a group of 2 terms for the first and 2 terms for the second. And deal with each of them separately. If I take the first group of 3xy squared minus 6y squared, I can find a common factor over there. Because first of all, between the 3 and the negative 6, 3 is a common factor. There's no x common factor, but there is a y squared. So therefore, there's a y squared on both of them. So y squared is a common factor. So in that first group, 3y squared is a common factor. And what we're left with in our parentheses, well, let's divide. 3 into 3 cancels. The x just comes down. The y squared into the y squared cancels. In other words, when I divide the 3y squared into the 3xy squared, I'm left with plain x. And then I do 3 into negative 6 is negative 2. The y squared cancels out. In other words, if I just take the first group of 2 terms, I can factor it into 3y squared and x minus 2. Now I go to the second group of 2 terms. And look if I can find a common factor. It doesn't have to have anything to do with this. Its own common factor. And so the first thing I see is that there's a plus in between them. So this is going to be a plus. And between 4x and negative 8, 4 is a common factor. Because 4 goes into 4 and 4 goes into 8. And again, I put my parentheses. 4 into 4x gives me x. And 4 into negative 8 gives me negative 2. Okay, let me just erase this now. Now let's just erase this. I use that to separate. And if you notice something, this is exactly what we had before. We now see, it doesn't always happen, but now in this example, it happened that we have a common binomial factor. And x minus 2 is a factor of both of them. So I could do what I did before and put the x minus 2 in the front. And then remember, I put the 2 other terms that are on the outside in my second parentheses. So it would be 3y squared plus 4. So I have taken this 4-termed expression and factored it into 2 binomials. What does that mean? It means if you wanted to check it, you could take this binomial and multiply it by this, and your answer should come out to be that. We have factored, we've taken, and our final, it's like going backwards. We have the final answer, and we want to go back to what were we originally multiplying. Okay, I'm going to do another example like this because I think you should see one, and then I'll give you one to try also. Okay? So let's say I gave you this example. AB plus 5A minus 3b minus 15. Okay, again, I have 4 terms. Again, this grouping method works when we have 4 terms. And I can't combine any of them, and there's no common factor of all of them, because even though 5 goes into these two, it doesn't go into this. There's no common factor throughout. So again, I tried this grouping. I break it down into 2 binomials, 2 in the front, 2 in the back. And I take the first group, the AB plus 5A. And I see there's no number because this is a 1, so there's no common coefficient, but there's an A in both of them. I could put the A on the outside, and A into AB, the A's cancel out, leaves me B. And A into 5A, again, the A's cancel out, and it leaves me A plus 5. B plus 5, so it's AB plus 5A can be factored into the A in the outside, B plus 5 in the inside. Okay, now let's look at our second group, the negative 3b minus 15. Okay, now what's interesting about here is that the first number of the group happens to have a negative. Anytime you're looking for a common factor and your leading coefficient, what you're starting out with is negative, part of your common factor is the negative. So I'm going to keep as part of my common factor the negative, and between 3 and 15, 3 will go on into both of them. In other words, negative 3 is a common factor of the negative 3b and the negative 15. Looks what happens when I divide the negative 3 into the negative 3b, the negative 3's cancel out, that leaves me with b. And when I divide the negative 3 into the negative 15, I get positive 5. Be careful with your signs. A negative into a negative gives you a positive. And I'm going to get rid of this. And again, I have that same situation where I have a common binomial factor. The common binomial factor of b plus 5 goes first in one parentheses. In the second parentheses, it's whatever on the outside, which is the A minus 3. And again, I took this 4 terms and got it down to factor to a binomial times a binomial. You think you're ready to try one of this kind? Okay, let me put one down for you. So I'll give you this one, 2x cubed plus 3x squared plus 8x plus 12. Okay. I'm going to give you a couple minutes to see if you could factor this 4-termed expression by grouping into 2 binomials. Okay, I think we had enough time. Again, if you look at it, there's no common factor between all the numbers. This is a 2, a 3, an 8, and 12. Nothing goes into all of them. So again, we're going to try and do our grouping, taking the first group between the 2x cubed and the 3x squared. There's no common number, but the x cubed and the x squared, remember, you always take the lower exponent, will give you x squared. So in my parentheses, I'll get, well, x squared into 2x cubed will give me 2x. And x squared into 3x squared, those x squareds cancel out and it leaves me 3. That's my first group. Now I go to my second group, where I have an 8x and a 12. So between 8 and 12, there's a common factor of 4, and it's a positive 4 because this is the leading coefficient is positive. Remember, if this is positive, then you bring down a plus. If this would have been a minus, you would have bring down a minus. 4 into 8x gives you 2x. And 4 into positive 12 gives you positive 3. And again, now this doesn't always happen. You don't always get a common binomial factor. But in this case, we do. We have a common factor of 2x plus 3. That goes in the front. And on the second parentheses, we do the x squared from the first and the plus 4 from the second. And this would be your answer. I hope everybody was able to get that answer. That is called grouping by, factoring by grouping. And that's the second type of factoring we have talked about. Okay, so now let's go to a third type of factoring. And this is something that is just a matter of you look at the pattern. It's a pattern, and we actually talked about it. It's called the difference of squares. Okay, let's keep in mind, when you're looking for greatest common factor, you could have as many terms as you want. Usually it doesn't go more than 3 or 4, but there could be 20 terms. When you're doing grouping, you have 4 terms. It turns out the difference of squared only applies when there are 2 terms. This is 4 terms. And this is going to be 2 terms. Now, what do we mean by the difference of squares? It means that your first term is a perfect square, and your second term is a perfect square, and difference means there's a minus. You're going to have a binomial where the first is a perfect square minus a perfect square. Difference of squares. That expression always comes around from being the product of 2 conjugate binomials. This, you just have to notice the pattern, and then you can immediately factor it into 2 binomials. Now, what I should say is, first, of course, you look if there's a common factor, which there isn't. If there's a common factor, you always deal with that first. But if there's no common factor, if you have the difference of squares, right away write 2 parentheses. Your answer is going to be 2 binomials. You take the square root of the first term, the 4x squared. What is the square root of 4x squared? Well, the square root of 4 is 2, and the square root of x squared is x. So this, you put 2x into each parentheses. You do the same thing with the second number, the 25. You find the square root of 25. It happens to be 5. You put the 5 in each parentheses. And then in one parentheses, you put a plus, and the other parenthesis, you put a minus. In other words, you get 2 conjugate binomials. Remember, we just talked about that. When you're multiplying conjugate binomials, you don't have to do the whole FOIL because the inner and the outer cancel each other out. So when you see that your final answer is the difference of perfect squares, then it's very easy to factor by just taking the square root of the first term and the square root of the second term, you put them in each parentheses, but in one you put a plus and one you put a minus. Let's say I gave you something like this. 25y squared minus 100. Let's say I wanted you to factor this binomial. Now, first of all, I first look for a common factor. Is there a common factor? Yes, there is, because 25 goes into both terms.
Call from list.
There is a common factor of 25. The first thing I have to do is deal with the greatest common factor. I'll put the 25 on the outside, and I will factor out 25 into 25y squared gives me y squared. 25 into negative 100 gives me negative 4. So I look, in any case, this is always going to be my first step. See if there is a common factor. After I've taken out the common factor, if I have 4 terms, I'll try to do grouping. If I have 2 terms, then I look if the 2 terms are perfect squares with a minus. It can't be a plus in between them. It has to be the difference of 2 squares. Well, that's exactly what I have. This is a perfect square minus a perfect square. So in that case, I leave the 25 on the outside and I write my 2 parentheses. I put y into both of them. Square root of 4 is 2, so I put 2 into both of them. And when I put a plus and when I put a minus, and it doesn't matter if you put the minus in the first one and the plus in the second one, but one has to have a plus and one has to be a minus. And that would be the answer to factoring this 25y squared minus 100. Okay, let me see if I can give you one to try. Suppose I gave you this example. Four x squared minus 49. Let's see if you could factor that. Okay, I think we could do that. First of all, is there a common factor here? And the answer is no, because 4 doesn't go into 49 or 2, there's no common factor at all. But 4x squared is a perfect square and 49 is a perfect square. So I break it up into my 2 parentheses. The 4x squared, I put 2x and 2x. The 49, don't forget, 49 is 7 times 7. So you put a 7 and 7 in both, and again, a plus in one and a minus in the other, and you get 2x minus 7. And so that's the third type of factoring. The fourth type of factoring, and then we'll look at it, is when you have a trinomial. And actually, that's the most common type of factoring that you're going to encounter, trinomial factoring. I'm going to start it today. This is something that takes a little bit of work. I'm going to start it today, and then we're going to go on with it on Thursday. We will finish it on Thursday. And of course, when you have trinomial factoring, the actual word means 3 terms. So it's going to be easy to tell which type of factoring you're going to want to go to based on the number of terms it is. If you have more than 4 terms, the only thing you're going to be looking for is a common factor. But if you have exactly 4 terms, you'll try and do grouping. If you have exactly 2 terms, you'll try to do difference of squares. Not everything can be factored. Some things are prime, just like numbers are prime. Just like 17 can't be broken down any further, some of our expressions, our algebraic polynomials can't be broken down. But if these are what we look for when we have 4 terms, this is what we look for when we have 2 terms, and then we have, what if we have 3 terms? So I'm going to show you how to deal with something with 3 terms. And actually, I'm going to do it. You may have methods, you may have learned different methods with in other classes. And if you have a method that works for you, just keep using it. I'm going to use the method that I call grouping. I'm going to be using the grouping method to factor trinomials. And you're going to say, how is it possible to use grouping when a trinomial only has 3 terms? Well, in order to explain it, let me show you what happens when you multiply 2 binomials. Let's say I have the binomial x plus 2 times the binomial x minus 1. Well, let's do x plus 5. Let's do an easier one. We know when we're multiplying 2 binomials, we use FOIL. First is x times x is x squared. Outer is 5x. Inner is 2x. And last is 2 times 5 is 10. Actually, whenever we multiply 2 binomials, we end up with 4 terms. We end up with a 4-term expression. Except usually what happens is the 2 middle terms, the inner and the outer, are like terms, and they can be combined so that we end up with x squared plus 7x plus 10, which is a trinomial. But the reason we end up with a trinomial is not because we originally had 3 terms when we multiplied. We actually had 4 terms. It was just that we combined 2 of those terms. Okay, that's what happens when we multiply x plus 2 times x plus 5. Okay. I'm going to do, remember, factoring is undoing multiplication. What happens if I gave you the x squared plus 7x plus 10, and I told you I wanted to factor it? This method is also sometimes called the AC method. Okay, how do we do the AC method? The A stands for the number in front of the x squared. The C stands for the last number. The AC method means multiply the A, which is the coefficient of the x squared, with the C, which is the standalone number. So in this case, 1, my A is 1. I'm just putting it over here. And my C is 10. So my AC turns out to be 10. Obviously, when your leading coefficient is just a 1, your AC is just the last number. That makes sense. But sometimes there's a number in front of the x squared, so that's why we include it. Okay, now, if you think about it, we want to take this 7x and somehow break it back up into the original outer and inner, because if I could do that, then I can use grouping. Yes. Akeem, you have a question?
No, I was trying to say that the AC would give you back D, but you're doing it right now. So
Okay. So here's what I do. I take my AC and I look at the number in the middle here. I forget about the x, just look at the number. I am going to try and find two numbers that multiply to this 10, that AC. And when I add it, and I'm going to know it's going to have to be added because this says plus, when I add them, they're going to add to that middle number. So that's what I do. I figure out my AC. I usually don't put in the plus, but I have to keep in mind it's a positive 10. So I'm looking for two numbers that are going to multiply to positive 10, but when I add them, they're going to add up to positive 7. Now, can you think of any numbers that work like that? Two numbers that multiply to 10 and add up to 7. And yes, Akim, you're absolutely right. One number is a positive 2 and one number is a positive 5. Which means I'm going to take this 7x and break it up into a positive 2x and a positive 5x. I want to, remember, I have a trinomial, but my method is using grouping, needs really 4 terms. So I have to take this 7x and somehow break it back up into the original 2 terms it was. Again, there are many ways of breaking up 7x, but I want to specifically get two numbers that multiply to the last number and add to that middle number. Now, so what I've done now is I figured out this 7x I can break up into the 2x and the 5x. I bring down the other 2 terms. In other words, I bring down the x squared that was originally there. I didn't deal with it. And I bring down the 10. The only thing I split up was this little term in the middle, that was really the result of combining 2 terms. So I split my middle term into 2 terms so that I end up for my 3 terms, my trinomial, I have now 4 terms. And once I have 4 terms, I can then do grouping. My first group is the x squared and the 2x, which has a common factor of x. So I'll put x on the outside and x plus 2 on the inside. My second group is 5x plus 10. So therefore, my common factor in that second group is 5. So I put the 5 on the outside. That 5 into 5x gives me x. 5 into 10 is 2. And just like we did before when we had grouping, we have a common binomial factor. We put in front the x plus 2. And in the second factor, parenthesis, we put the x and the 5. And now we have taken our trinomial, the x squared plus 7x plus 10, and broken it down into its original x plus 2 times x plus 5, the two binomials that originally gave me this expression. Okay? I'm going to do one more and then I'm going to leave it. At this point, you can do the first 3 types of factoring. I'm not going to give you homework on trinomial factoring until next time, but there will be homework on factoring because we've learned 3 types. And we're going to look at one more example where we can use this AC method. Let's say I had x squared minus 3x minus 18. Again, here I have a trinomial, and I want to factor this trinomial into 2 binomials if it's possible. Again, it's not always going to be possible, but we're going to try. Again, it's a trinomial, so we're going to use our AC method. Remembering my A in this case is 1, and the C is negative 18. In other words, my AC is negative 18. Now this one is negative, so we're going to have to be careful. Okay, again, let's think what we want to do. We want to find 2 numbers that multiply to AC. We need 2 numbers that are going to multiply to negative 18. Now before, remember, we had a number that was a positive number. Now we have a negative number. And we have to keep in mind that when we multiply 2 numbers and our answer is going to be negative, one of the numbers is going to have to be positive and one of them is going to have to be negative. So we're going to be looking for 2 numbers that multiply, one positive and one negative, to negative 18, but when I combine them, I get negative 3. Now remember, since I'm combining, these are a negative, I'm combining a positive number and a negative number, which really means that I'm going to be subtracting. Can you think of any numbers that multiply to negative 18, but when you combine them, when you, so to speak, add them, will give you negative 3? Well, let's just think. What multiplies to 18, but when I subtract them, it gives me 3. And obviously the numbers are 6 and 3. Because 6 times 3 is 18. The question is, which one should be the positive and which one should be the negative? Because since this is negative, one of my numbers is going to have to be positive and one of them is going to have to be negative. But since when I combine them, the final answer is negative, it means the larger number has to be the negative. So it has to be a negative 6 and a positive 3. Notice, positive 3 times negative 6 will give me negative 18. Positive 3 plus negative 6 will give you negative 3. So I've got the right combination. So now I'm going to rewrite this trinomial as 4 terms. I'm leaving my x squared alone. I'm writing my next term to be plus 3x. I have to put the letter next to it. These are just the numbers. My next term will be negative 6x. And my final term will be negative 18. In other words, I changed this negative 3x into a positive 3x minus 6x. Notice 3x minus 6x is negative 3x. I've just broken this down to something that was originally what it originally was. So now I can do my grouping. In my first group, I have an x as a common factor. So I do x times x plus 3. In my second group, I have a 6 as a common factor, but actually a negative 6 because that middle term, the first term of that second group is negative. So I put the negative 6 on the outside. Negative 6 into negative 6x is x. Negative 6 into negative 18 is positive 3. And now I have a common binomial of x plus 3. So that goes first, and my x minus 6 goes second. And then again, I took a trinomial, expanded it to 4 terms so I could use grouping. Again, what did I do? I found my AC by multiplying the very first number, in this case it's 1, times the very last number, that's what's called AC. That gave me negative 18, and I looked for 2 numbers that multiplied to negative 18, but when I combined them, when I added those 2 numbers, I got negative 3. And those 2 numbers were the positive 3 and a negative 6. Okay, this is where we're going to end off today. Don't forget to look for homework on Delta Math. If you didn't complete the test yet, make sure you do it because no more extensions. Okay. And we will continue using this AC method next time. Have a good day. I'll see you on Thursday. You too.
Have a good day, Professor.
Bye-bye.
But